Hi class, I apologize for not being in school today, especially the third hour since I was gone yesterday for park training, but I am at home today with my son who is sick. So I'm going to go ahead and do this explain everything, and hopefully we'll be able to keep up with the material. Please realize that tomorrow is a review day. I have some newer ideas still to go over with you, but I will have time to go over any questions from the last few days, and I will be back as long as I don't get the stomach flu that he is currently experiencing. So here we go. So take out a sheet of paper. We are starting day 3. And make sure you guys pause it if I'm going too fast. Okay, so this is day 3. Seven 7.3 arithmetic and geometric series. So yesterday we developed the 2 formulas to come up with your first term, your last term, or your N, or your R, or your D. We were working more with sequences. Today we are working with series. And we know series are just the sum of our sequence. So the first one that we're going to do is part 1, is the arithmetic series. Which is defined as the sum of the terms of an arithmetic sequence. My handwriting is horrible on this, I apologize. Okay, so today we're going to come up with a formula of how to find the sum of any arithmetic series. Rather than just give you the formula, let's go ahead and come up with it. So to do that, we're going to find the sum of the arithmetic sequence from a sub 1 to a sub n. Okay, so I'm going to go ahead and I'm going to write this out in expanded form. I'm going to say S sub n. And rather than writing it as a sub 1 plus a sub 2, I'm going to use what we learned yesterday. A sub 1 stays as a sub 1. A sub 2 is the same as a sub 1 plus d. A sub 3 is a sub 1 plus 2d. And I could keep going at this, but I'm going to say that takes me all the way up to my a sub n, which we know is a sub 1 plus the quantity of n minus 1 times d. So that's yesterday's arithmetic sequence formula. Well, that doesn't get me anywhere. But if I go ahead and add that same sum, starting from a sub n and working my way to a sub 1, something nice happens. So I'm going to start with a sub n. Well, to get to my next term, that a sub n minus 1, that's really my a sub n minus d. And then the term before that would be a sub n minus 2d. All the way down to our a sub 1, which rather than writing it as a sub 1 is really a sub n minus the quantity of n minus 1 times d. Take a minute to look at that. And I know that this is not a natural thing for you to go and say, oh yeah, I would have done that, but try to follow along. By us doing this, if we add these two sums, we will get 2 s sub n. Adding down, a sub 1 plus a sub n is just a sub 1 plus a sub n. And then if I add my a sub 1 plus d and my a sub n minus d, well, I've matched those up intentionally so that the d's cancel out, leaving us with another a sub 1 plus a sub n. Continuing this pattern, a sub 1 plus 2d plus a sub n minus 2d gives us an a sub 1 plus a sub n. And that's going to continue all the way down to the end, which leaves me with another a sub 1 plus a sub n. Well, how many of those a sub 1 plus a sub n's do we have? N. Therefore, I could rewrite this as 2 s sub n equals n times the quantity of a sub 1 plus a sub n, leaving us with s sub n to equal n over 2 times the quantity of a sub 1 plus a sub n. And that is our first of two formulas for today. If I am asked to find the sequence, or excuse me, the series of an arithmetic sequence, I would use this formula. S sub n equals n over 2 times a sub 1 plus a sub n. Uh-oh. Ignore all that. Okay, so here we go. Next one. So let's actually try an example. Number 1. Find S sub 35 for the arithmetic sequence of 2, 5, 8, 11, dot. So obviously I don't want to have to go and find my first 35 terms and then add them. I'm going to instead use yesterday's formula and today's formula. So the first thing I need to do is I'm looking at my S sub n formula, which is n over 2 times a sub 1 plus a sub n. Well, what's our n? What's our number of terms? 35. A sub 1 we have as 2. But the one thing we're missing is a sub n. So I'm going to list that out. Let's see. We know a sub 1 equals 2. N equals 35. We need our a sub 35. So that's our first plan of attack. This goes straight back to yesterday, where we had that formula a sub n equals a sub 1 plus the quantity of n minus 1 times d, which will allow me to find a sub 35. A sub 35 equals 2 plus 35 minus 1 times our d of 3. And I should have written that down. D equals 3. Well, simplifying that out, we get a sub 35 equals 2 plus 34 times r3, which is 102. And we end up with a sub 35 is 104. But be careful, that's not what the problem was asking for. The problem was asking for the sum of the first 35 terms. Well, we have everything we now need. So using this, I'm going to use my new formula. S sub 35 is equal to our n of 35, since we have 35 terms, over 2 times the quantity of our first term, 2, plus our 35th term, our last term, of 104. Putting that together, we get S sub 35 equals 35 halves times 106, which gives us 1,855. Much quicker than finding out those 35 terms and then adding them all up. Okay, number 2. Find a sub 1 and d for the arithmetic sequence if S sub 31 equals 5,580 and A sub 31 equals 360. Okay, so we've got a lot going on here. First thought is I see the A sub 1 and D. Oh, that's just yesterday. But the difference here is I actually have that sum of the first 31 terms, which means I'm going to need that to hopefully get to that A sub 1 and D. So I'm going to start with here. There had to be a purpose to start with. And I know that my S sub 31 is 5,580. And I'm trying to go from A sub 1 to A sub 31, which means that my n, as I'm plugging into my arithmetic series formula, is 31 over 2. I do not have my A sub 1, but I do have my A sub 31 as 360. Well, let's go ahead and simplify this. I'm going to go ahead and I prefer just to get rid of that 3 over 2, so I'm going to multiply by 2 31st. You could also distribute, leaving me with a nice 360 equals A sub 1 plus 360, giving us now an A sub 1 of 0. Okay, so we use today's formula to come up with our A sub 1. Now we're going to go back to more of topics from yesterday. Because now we have to go ahead and find our D. For this, I have my A sub 31 is 360, and I have my A sub 1 equals 0. And we're back to exactly what was going on yesterday. Plugging it into my A sub n equals A sub 1 plus the quantity of n minus 1 times d. I'll write that down in case you need it. We will get, well, our last term is 360 equals our first term is 0. I'm going from my first term to my 31st term, so n is 31 minus 1 times our d, resulting in 360 equals 30d, and d equals 12. Okay, next one, number 3. We are going to evaluate the sum. So going back to day 1, the summation from 5 to 19 of -3 minus 4. Okay. Okay, on Monday when we talked about what the summation is, we did expanded form. You do not want to use expanded form for terms 5 through 19. That's just a waste of your time. Instead, looking at this is that linear function, which tells us that it's arithmetic. It's going down by 4. So I can use my S sub n equals n over 2 times a sub 1 plus a sub n, but before I can use that, I have to find all those missing pieces. So let's see, S sub n, if I'm going from 5 to 19, my n is 15, not 14. Remember, 19 minus 5 plus 1. 19 minus 5 plus 1 over 2. My a sub 1, remember, is really my a sub 5 here. So my first term starts at 5. So I'm going to write a sub 5 equals -3 minus 4 times our 5, giving us -23. So that's going to go in as my first term that I care about. And then my a sub 19 is my last term, -3 minus 4 times 19, giving us a sub 19 equals -79. And I'm going to place that in as a sub n. I have everything I need now to find out that my S sub n is equal to -765. Okay, last one of this type. We'll move on to our geometric. Number 4. Find n for the series with a sub 1 equaling 6, d equaling 3, and s sub n equaling 132. Depending on time, we still do have probably at least 15 minutes more notes. If you want to pause this to try it on your own, feel free. But I'm going to go ahead and start. Normally I would have you guys try this on your own, but it's tough when I'm talking to you through YouTube. Okay, so I see that S sub n, so I'm going to start there. I know S sub n equals n over 2 times the quantity of a sub 1 plus a sub n. Well, let's fill in what we know. 132 equals n. Well, that's what we're looking for, so n over 2 times the quantity of our a sub 1, which is 6, plus our a sub n, because that's not known. Well, I don't want two unknowns. I don't want n and a sub n. Well, my whole goal is to solve for n, so that's probably fine. I think it's this a sub n that we can work with. From yesterday, I can go ahead and realize that a sub n is equal to my a sub 1 of 6 plus the quantity of n minus 1 times our d of 3. So better yet, a sub n is really 6 plus 3n minus 3, or a sub n equals 3n plus 3. Well, if I substitute this back in for a sub n, I now will have an equation only in terms of n. And I know I can handle this now. 132 equals n over 2 times the quantity of 3n plus 9. Many different ways of going about this. I generally like to go ahead and get rid of that divided by 2. So I multiply both sides by 2, leaving us with 264 equals n times 3n plus 9. Or, better yet, 264 equals 3n squared plus 9n, leaving us something that we can most likely factor. 0 equals 3n squared plus 9n minus 264. Seeing that 3 and 9, I'm going to see if the GCF is 3. And thankfully 3 does go into 264, giving me 0 equals 3 times the quantity of n squared plus 3n minus 88. Factoring into 0 equals 3 times the quantity of n plus 11 times n minus 8, giving us the final result of negative 11, or n equals 8. And from here we can say that the number of terms, so n is 8. Okay, feel free to pause this. I'm not sure, I think I've talked too fast on that. Okay, last section now is the geometric series. Okay, just like arithmetic, the definition is the sum of the terms of a geometric sequence. And we're going to go ahead and find this formula as well, much like the last one. Find the sum of the geometric sequence a sub 1 plus a sub 2 plus a sub n. Okay, I'm just going to write this out. S sub n equals a sub 1. And rather than write a sub 2, what we talked about yesterday is that a sub 2 is really a sub 1 times r. A sub 3 is a sub 1 times r squared. Plus dot 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 all the way to a sub n, we know is a sub 1 times r to the n minus 1. Now, like I said in the last one, this one is not natural. I'm not sitting there thinking that, oh, I have this idea. But what you want to look at now is I'm going to do the same S of n, but I'm going to multiply it by r. So right below it, I'm going to write r times S of n. And I'm going to try to line things up to match again. So I'm going to skip this a sub 1. Therefore, now I'll have a sub 1 from originally times r. Then I know my second term is a sub 1 times r, but times r again is a sub 1 times r squared. Excuse me. Now this might seem strange, but my last term is not a sub 1 times r to the n minus 1. It's actually a sub 1 times r to the n. So my second to last term matches up here. Is a sub 1 times r to the n minus 1. And my last term is a sub 1 times r to the n. Because I multiplied by that extra r. Now rather than add these, I'm going to go ahead and I'm going to subtract these. I will get s sub n minus r times s sub n equals just good old a sub 1 minus a sub 1 times r to the nth. And we got to do a lot of cleaning up here. So on the left side I have s sub n minus r times s sub n. I'm going to factor out that s sub n, leaving me with 1 minus r. And on the right, I'm going to factor out an a sub 1, leaving me with a sub 1 times the quantity of 1 minus r to the nth. And since I want to find the formula for the geometric sequence, I want to find the s sub n, I'm going to get s sub, excuse me, my husband sneezed and I jumped. S sub n equals a sub 1 times the quantity of 1 minus r to the nth all over 1 minus r. And 1 minus r does not cancel out that 1 minus r to the nth. Giving us our second of two formulas for today, or our fourth total for the chapter. You need to be comfortable with this formula, not so much on how we came about it. You're not going to have to recreate it. You need to be able to use what we have now. S sub n equals a sub 1 times the quantity of 1 minus r to the nth all over 1 minus r. Okay, so let's try one. Find the sum of the first 10 terms of the series 3 plus 6 plus 12 plus dot dot. Okay, just for practice, s sub n for a geometric series is equal to a sub 1 times the quantity of 1 minus r to the nth all over 1 minus r. Well, we have everything we need. S sub n will equal, our first term is 3 times the quantity of 1 minus, well, to go from 3 to 6 and then 6 to 12, our r is 2. We're looking for the sum of the first 10 terms, so we have an n of 10, all divided by 1 minus 2. Be very careful here. 3 times the quantity of 1 minus 2 to the 10th over, essentially negative 1, comes out as a sum of 3,069. Okay, number 6. The summation from 1 to 7 of 3 times negative 2 to the I. Okay, so right here, the fact that I have negative 2 raised to a power means I am constantly multiplying by negative 2. So right away I know because of this, I have an R of negative 2. It is geometric. I know it's in a different form. It's just saying, once again, find me the sum. Okay, so a sub 1 is needed before I do anything. That's going to be 3 times negative 2 to the first, which is negative 6. Do I have to find my a sub n or my a sub 7 here? No, it's not needed for our formula. S sub n equals our a sub 1, negative 6, times the quantity of 1 minus our r of negative 2, so be careful, it's the quantity of, raised to the nth power. Well, I'm going from 1 to 7, so that's 7. That doesn't instantly make this a positive. I have to first think about what is negative 2 to the 7th, and then I can see if it makes a positive. All divided by 1 minus that negative 2. Resulting in negative 6 times the quantity of 1 minus negative 2 to the 7th is a negative 128 over 3. And we get S of n equals negative 6 times the quantity of it will be 1 plus 128 or 129 over 3. And our final sum equals negative 258. Okay, last one. The summation from 2 to 5 of 243 times 2/3 to the j. Okay, this wouldn't be that bad to just add up, but I do want you using our new formula. So right away, when I see 243 times 2/3 to the j, I instantly know geometric because I have 2/3 to the j, which means I'm doing 2/3 to the first, or 2/3 to the second, so it's 2/3 times 2/3 times 2/3, and so forth. So right away, I know my r equals 2/3. Only other thing I need to know is my first term and my n. Well, be careful. I am not finding a sub 1. I am truly finding a sub 2. That is my first term here. So a sub 2 will equal our 243 times the quantity of 2/3 to the second. A sub 2 will equal 243 times 4/9, which reduces to a sub 2 equaling 108. Okay, time to plug in. S sub n equals our a sub 8, or a sub 1 of 108 times the quantity of 1 minus our 2/3. What's our n? I'm going from term 2 to term 5. 4, right? 5 minus 2 plus 1. All over 1 minus 2/3. S sub n equals 108 times the quantity of 1 minus, well, let's see, 2/3 to the 4th will result in 16 over 81. All divided by 1/3. Yeah, you could carefully plug this in your calculator, but I'm going to go ahead and do it without. Got that 108. Well, 1 minus 16 over 81. That 1 is like 81 over 81. Which gives us 65 over 81. And instead of dividing by 1/3, I'm going to go ahead and multiply by 3, or 3/1. And you could use your calculator here once again, but I'm going to say, okay, this 3 and 81 reduced to 1 and then a 27. And I know that 27 goes into 108 4 times. And I am now left with S sub n being 4 times 65, which is 260. Okay, this is on Schoology in case I talk too quickly through it. I also have put the completed notes up on Schoology, so please check those. Feel free, like always, to email me if you have any questions on day 1, day 2, or day 3 homework, and I will get back to you. I'm planning on being in the library as usual on Thursday morning if you need some extra help, unless for some reason I get sick. Have a great day, and hope to see you tomorrow.